All right, I think until I get a little more satisfied, I want to start off each session doing 5 minutes of this.
Okay.
Go ahead.
Uh, 5, 6, 7, 8, 9, 10, 11, 12, -12, I think.
Okay, let's look at this. First of all, I hate the fact that you're doing it that way. When you
Like
add 7 to 2, you should not go 7, 8, 9. What you should do is memorize that 7 plus 2 equals 9. There's a
got it.
difference, okay? Because if I say 7 plus 8, it takes forever to count it out, right? You can't really go 7, 8, 9, 10, 11, 12. You lose track. So that is not the way to add numbers.
Okay.
Okay? It just isn't. Get over that habit. What you want to do here is very simple. Which negative sign is the subtraction sign?
The middle one.
So I'm going to change that to addition. And the moment I do that, I have to change the sign of whatever follows to opposite of what it was. Now the problem is -7 plus 5. What's that?
Oh, so -2.
Yes.
That's a little more complicated than I thought it would be.
Well, it is a little more complicated, but you don't ever make a mistake as long as you change that subtraction to an addition. Now, you don't need to do that if everything's positive. If I said, what's 7 minus 4? Well, you can do that. That's 3. But the moment you start putting a lot of negative signs in there, it throws people off.
Quick question, like if it was like -7 plus -5, would we just change the negative sign on the 5?
No,
Like,
there's no subtraction going on there.
oh, so we would have to
The
just like
only
add
time
them?
you do that is when you have subtraction. What you said was -7 plus -5, correct?
Yes.
There's no subtraction. That's addition. Those are negative signs. Those are not subtraction signs. So the first thing you have to do is be able to recognize where the subtraction sign is. If this is unclear, then put stuff in parentheses. If I put it like this, there's never any doubt, right? What is that?
That is 5, -12.
Yeah, you always get that one right. When you're
Okay.
adding two negative numbers, that's not problematic. Everybody knows how to do that. It's only when you are subtracting that it throws people off. And the way to solve that is just to turn it into addition. You don't have to ever do a subtraction problem, ever. It's just that if I have that subtraction problem, I can do that. I don't need to turn it into this, which would be the other way of doing it. In other words, I turn the subtraction sign into an addition sign and I change the sign on what was being subtracted. Well, if I gave it to you this way, you'd still get 3, but it would actually be a little harder. Whereas if I left it like that, you get 3 all day long. It's only that when you have a negative sign thrown in, that's when people get screwed up. There is your subtraction sign right there. That is a negative sign. And it's very important that you be able to recognize the difference as to when you have one and when you have the other. Okay, what's
Got it.
this?
This is, I don't know.
Okay, first of all, I want you to give me the sign.
It is a times multiplication.
What's the sign of the final answer? Is it going to be plus or minus?
Minus.
When I multiply a minus times a minus,
Oh, they cancel out, so it would be a positive.
they become a plus. So that's the first thing I want you to answer on all these questions. So I want you to give me the sign first,
Okay.
especially in multiplication and division problems. Now, 8 times 9.
8 times 9. So,
I'm going to show you a nice little trick that's going to eliminate the need for you to to memorize 9 of these things. Remember your multiplication tables, there's 100 spots in it, but I can take away 50 of them instantly. If I can get my thing to come up. There we go. Wait, hold on a second. Wow. This Windows Ink workspace does not work very well. Ever since I've had Windows 10, I've had troubles with this thing.
I love Windows 10, but that's coming from a gamer.
Yeah, oh, here we go. I finally got it to work. Okay. Let me tell you a little trick. Very useful little trick. 2 times 9. Whenever you multiply a number by 9, you get an answer where all the digits add up to 9.
Yeah.
Notice?
I don't know that.
By noticing, I mean 1 plus 8 is 9, 2 plus 7 is 9, 3 plus 6 is 9. And the first digit is 1 less than what you're multiplying the 9 by. So what's the first digit in 5 times 9?
5 times 9.
First digit is always 1 less. 1 is 1 less than 2.
Oh, it would be 4.
And what's the second digit have to be if they're going to add up to 9?
It would be 5.
6 times 9.
Would be 5 and 4.
7 times 9.
45.
What's the first digit?
No, 43. 43.
What's the first digit?
Oh. 6.
In other words,
I don't know.
if you don't know what the first digit is, you can't figure out what the second digit is. Once you figure out the first digit, just know the second digit has to add to 9.
Yeah.
8 times 9. First digit
is 7.
Second digit
2.
9 times 9. First digit
8.
Second digit
1.
Now, that system holds true for all single digits. When I get to 12 times 9, I get 108. Well, notice those all add up to 9 also. So it doesn't matter what I'm multiplying 9 by. I can be multiplying 9 by 173, and I'm going to get an answer where all the digits add up to 9.
Oh, it actually makes sense now.
That's a wonderful thing to know. That means that I can give you a big old long number like 1017. Is that divisible by 9?
No.
Yes. The digits
yes.
add up to 9. If the digits add up to 9, it's divisible by 9. If I'd have made it 1016, they do not add up to 9. That is not divisible by 9. So if you want to know if a big number is divisible by 9, just add up the digits. If they add up to 9, it is. If they don't, it does not.
So
But
does
it
that work
also
for,
helps tremendously in your multiplication tables.
does that work for like any number? Really? Like,
Just 9. It's the rule. It's called the rule of 9s. Now, the reason I said that'll only take care of 10 is because you have 100. When you're trying to memorize your multiplication tables, what you have is this. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you have a cell for each answer, right? Well, there's 100. There's 100 cells here, 10 by 10. Okay? Now, a lot of them are automatic. You certainly don't need the 0 cell. You know that 0 times any number is 0. So I don't need that row. I don't need that column. So that takes care of 10 of them immediately. 1 times any number is that number. So you don't need that. And you don't need this. 2s. I bet you know your 2s. Everybody knows their 2s.
yep.
So you don't need that. By the time you get done, and if I tell you a little neat trick for 9s, you don't need to memorize your 9s. You don't need to memorize the 5s. I'll bet you know your 5s perfectly.
Yeah.
The tough ones are 6, 7, and 8. So what is
Yeah.
that? Is 10 times 3. There are only 30 that you have to memorize. And there's not even 30. Because when you do your 6, 7s, and 8s, you don't need to memorize the 9. You know what that is. You don't need to memorize the 5s. You know what that is. You know what the 2s are. So now you're down to about 20 numbers you got to memorize. So out of 100, you're down to 20 that are tough. That's it. And that's why I say that if you use this program for 10 minutes a night, you'll be done. You'll have it memorized. It's not that hard. This program will give you all of the tough ones enough times that you'll memorize it. Now, I don't need to write the plus sign here. Go ahead.
Minus x is 6.
Whoops, hold on. I typed 67. Okay. Oops. I'm getting ahead of myself. Go ahead.
6.
What's 7 minus 11?
7 minus 11 would be 4.
Okay. Here's another rule. If you have a bigger number minus a smaller number, your answer is positive. If you have a smaller number subtracting a bigger number, your answer always has to be negative.
Okay. So it would be negative 4.
Go ahead.
It would be 3.
Very good.
It would be 7.
Good.
Okay.
Don't worry about these. And the way I would do this is I would say that's 10 times 12 plus 1 times 12. Well, 10 times
This
12
is
is
1.
120 plus 12, that's got to be 132. Okay? How about this? I'm more concerned with these.
1.
I don't really care if you know how to do 2 digits by 2 digits. I really don't. You can use a calculator for those. But it's the single digit by single digit that you've got to know.
Okay. 1.
Okay?
0.
Ooh.
1. It's 1.
Actually, it's undefined. They should not have put this one in here. I don't know what the correct answer is. It's undefined. It's actually called indeterminate.
Can we click like SOS or like check question or something?
Well, let's answer a couple of things. Didn't like 0. It's going to like 1. All right.
Okay.
No, that's not the correct answer. But that's the stuff of higher mathematics, not Algebra 1. You don't learn that until calculus. That 0 divided by 0 is not 1. It's indeterminate.
The first number would be 6.
Very good. First of all, what's the sign going to be? I want to know the sign first whenever you're doing multiplication
Positive.
or division, okay? First number is 6, correct?
Second number would be 5.
What adds to 6 to equal to 9?
3. It would be 63.
You got it. What's the
This would be 20.
You got it. See, these are easy.
Yeah. This would be 2. Okay.
What's the sign going to be? Division.
This is going to be negative. And this is going to be 1,000. No, 11,000.
When you are dividing by 10.
Oh, dividing by 10. It's 11.
Yeah.
11.
You knock a 0 off. When you're multiplying by 10, you add a 0. But when you're dividing by 10, it's the other way. Okay.
I got confused.
I can see you're getting better here.
5. The first number is 5.
The way to do this, first of all, this is 6 times 3. So it's 6 times 6, or excuse me, it's 6 plus 6 plus 6. That's what 6 times 3 means.
Oh, 6 plus. So, I was like trying to. So would the first number be?
No, you can't use your rule of 9s on this.
Oh.
This is not a 9. The only way the best way to get this is to memorize it. And that's what you will learn by working with this 10 minutes a night. Is by 18. The time you're done, it'll be 18 and you won't even realize you've memorized it.
0.
No.
No, 1. 1.
What's
negative 1?
Give me the sign first. Negative 1.
Negative 1, yes.
Okay.
Negative 1.
Turn it into an addition problem.
Oh. I would still assume it would be negative 1.
Okay. Which is the subtraction sign?
The middle.
Okay, so if I turn that into an addition, that becomes...
Oh, negative 3?
Yes.
Oh. I thought because...
Once you turn it into an addition, now you're adding 2 negative numbers.
Okay. I got confused there.
That's all right. You'll lose that confusion quickly, I guarantee it. You're not going to take much time for this, and it's going to make an incredible difference in your math performance. What's the sign going to be, plus or minus?
It's going to be minus.
What's the first digit going to be?
The first digit is going to be 4.
What's the next digit going to be?
5.
Go ahead.
2.
Remember, when you have a smaller number minus a bigger number, your answer always has to be negative.
Negative 2.
What's the sign going to be?
The sign's going to be positive, and it's going to be 18. Minus, negative. Okay, so this is going to be positive 2.
Both of those minus signs turn into a single plus sign. So this becomes 12 plus 10.
Oh, 22.
Okay. All right. That's enough time on that, but I think we made a lot of progress there, actually.
Yeah.
So, did you send me anything, or you have any problems that you're currently wanting to work on?
So this week we have a standardized testing, but I'm a sophomore, so I'm doing the PSAT. So there's like nothing I can really do. But do you mind if I go ask my dad, because you to he wanted you to teach me something.
Okay, sure.
So I'll be right back.
Okay.
1 second. On hook. 1 second.
Like you and I were doing.
He wants to explain what he wants you to teach me.
Okay. Hi, Lauren.
Hi there. So what I was saying that I've noticed with Josh is difficult is the concept of multiple equations with multiple unknowns. So
Okay.
if you have three equations with A, B, and C,
Uh-huh.
and you need to solve for them, if you have three unknowns and three equations, you can always solve for it. And every time we've had to do two equations, two unknowns, or three equations and three unknowns, the concept of substitution has been a little soft. So I thought perhaps you guys could go over that.
Okay. We will.
Make sense?
Yeah. No, I know exactly what you're talking about.
Okay, great. I'll put him back on.
Okay.
There you go.
I'm
Josh,
back. Yep.
this is basically what we were doing yesterday, all night.
Okay.
Okay. We didn't
Like
do we didn't do any three equations and three unknowns, but we did an awful lot of two equations and two unknowns. And I went through some pretty hard ones. Let's just test you. First of all, tell me if you're going to use substitution or elimination.
Substitution. No, elimination.
Okay.
This is elimination.
Now, once you decide you're going to do elimination, are you going to add the equations or subtract them, or you have to first multiply them by something?
Subtract. No, wait, we have to multiply them to get actual
When
numbers.
you eliminate, always ask yourself, if I add the two equations, does anything disappear? Does a variable disappear? And if the
Yes.
answer is yes, then do that immediately.
So we would have to subtract.
No, I don't have to eliminate x. I have my choice. I can eliminate y or x. The way I have written this, you can add the two equations and y will disappear. That's the easiest thing to do. Always choose addition over subtraction if you have a choice.
Got it.
So Adam, what do you get?
We get 2x equals 10.
Nope, got to add everything, both sides.
Oh, 20. Sorry.
What's x equal?
X equals 20 over 2, or 10.
What's y equal?
Y equals 0.
There you go. Easy. Okay, now I'm going to make it a little harder. Actually, it's a lot harder. You're not going to find too many that are harder than this until we get to 3 equations and 3 unknowns. And we'll tackle that in a moment. But you got to be able to do all kinds of 2 equations and 2 unknowns before you have any shot at 3 equations and 3 unknowns.
All right.
So, am I going to use elimination or substitution?
I would say elimination.
Okay. Can I eliminate a variable by just adding or subtracting?
No.
Okay. Can I multiply one of the equations only by a number and then eliminate a variable?
Yes.
Which one?
3, the x variables.
Okay, hold on. I'm going to label these. Which equation? 1 or 2?
2.
What are you going to multiply it by?
I would say by 3.
Well, then that'll give you 6x plus 9y.
2?
Still not going to. Then that's going to give you 4x plus 6y. In other words, there is no single number that I can multiply either equation by such that I can eliminate a variable. But what if I multiply the bottom one by minus 3 and the top one by plus 2? Now, what's my new number 1 equation? After
Your new number.
Yeah, remove the parentheses.
Your new equation is negative 3 times 2 would be negative. Oh, 0. It would be number 1. Okay. Number 1 would be 6x plus by 2, 24.
Okay, the second part of that is that times that. What is 2 times minus 4y?
2 times, it would equal 8.
Yeah,
It would
8.
minus 8.
Yeah. In other words, it's this problem right here. 2 times minus 4. That's what it is.
Quick question. I think I remember this. So are we trying to create the equation so we could eliminate it?
Well, let's just continue with it and you'll get it.
Okay.
Do the second one.
The second one is 3 times, it would be negative 6x.
Keep going.
And then negative 3, it would be negative 9y.
Okay.
Equals 12, 13, 14, 15, 16, 17, 18. Negative 18.
Don't do it that way.
Don't do it that way.
Do not do it that way. That is not the way to do math. You will never ever advance beyond that way if you do it that way. If I told you what's 19 plus 18, you're not going to be able to do it that way.
Okay.
When you're multiplying 6 times 6, add 6 plus 6 plus 6. 6 plus 6 is 12. 12 plus 6 is 18. Memorize that. Don't count it up on your fingers. That is a horrible way to do math. Okay? So, my old equation no longer is going to be used. My old equation 2 is no longer going to be used. Notice now is all I got to do is add the 2 equations and the x is going to go away. That's why I multiplied by minus 3. I could have multiplied by 3 and I would have had 6x there and 6x there. But then I would have had to do subtraction in order to have a variable eliminate. By multiplying by minus 3, I ensured that this was going to be a minus 6. I knew the top was going to be a plus 6. That's all I need.
All right.
Now what?
Now we add the equations together.
Okay, what do you get? You're adding
We
that,
get
means you're adding
we get
that, and you're adding that.
so we get positive 1y equals
What's negative 8 plus negative 9?
negative 8 plus negative 8 plus negative 9 is negative 72.
Negative 17. Don't confuse
Oh,
multiplication
72.
and addition.
Oh, yeah.
You with me?
Yes.
Okay. In other words, whenever you have a variable, set the variable aside for a moment and work with just the numbers. In other words, what that problem is negative 8 plus a negative 9. If you saw it like that, you're never missing it. You're always getting it right. So just make sure that just because they're vertically aligned, it doesn't matter. It's still this problem. And the y goes along for the ride. You got minus 8 apples and minus 9 apples. When you add all of them together, you got minus 17 apples. What's the 24 plus a negative 18 equal to?
Minus 1. So it would be negative 18.
Okay, hold on before you answer it. Let me write it slightly different. That's the problem right there.
Okay. So it'd be 14 and then minus. It would be negative 4.
No.
Oh, what?
6.
Negative 6. Okay.
Not negative 6. 24 is the bigger number and it's positive. 8
Okay.
is the smaller number and it's negative. So when you're adding a positive number and a negative number, whichever number is the biggest absolute value, that's the sign of your final answer. Okay?
Got it.
In other words, if I add 24 plus a negative 23, I'm adding a positive number and a negative number. The positive number is bigger. 24 is bigger than 23. Therefore, my answer has to be positive. If I'm adding negative 24 to positive 23, I'm still adding a negative number to a positive number, but this time the negative number is bigger. 24 is bigger than 23, so my answer has to be negative. It's that simple, okay?
Okay.
All right. Now, I'm just going to show you 3 variables and 3 equations. Even though I'm not real fond of doing that. You're not expert enough yet at 2 variables and 2 equations. But I'm going to give you a relatively simple one, and I'm just going to show you the methodology.
All right.
Okay? There's 1 equation, 3 variables. Here's another equation.
Is this still a system of equations?
It is.
All right.
Second equation, 1 equation, 3 variables. Third equation. This is a system of 3 equations and 3 variables. It's like the 2 equations and 2 variables, only it's 3. You can also have 4. You can have 4 equations and 4 variables. In real life, you might have 100 equations and 100 variables. The key is as long as you have the same number of equations as you have variables, you can solve it. Let me just show you how to do it. It's a little complicated, but not that much. Okay? Here's what our goal is going to be. We are starting with equation 1, 2, and 3. My goal is to take two of those equations and see if I can eliminate a variable to get equation 4. Can you find two of those equations where you could eliminate a variable? And I don't care which a variable, x, y, or z.
Yes.
Okay, which two?
2 and 3, and it would be z and z.
Right, the z's are going to eliminate. So 4 is going to be 2 plus 3. And what is it going to be? Tell me what it is.
2 plus 3 would equal 5.
Hold on, add the x's.
Oh, add the x's. It would be 2 plus 3 would equal 9.
When I say 2 plus 3, I mean equation 2 added to equation 3. In other words, you're adding the x terms, you're adding the y terms, you're adding the z terms, and you're adding the numbers. So what do you get? You just added the x terms, now add the y terms.
It would be 4y
Minus 4y.
minus 4y.
And the z's go away, right? That gets eliminated.
Yeah. And then it would equal 10.
13. You got to add the numbers also.
Oh, sorry.
Okay. Now, the next part is extremely important. I want to create an equation 5 that is also missing z. And I can't use 2 and 3. I've already used 2 and 3. Can I find two other equations that will eliminate z?
Yes.
Plus 2.
1 plus 2. It would equal 3, but plus the variable.
You're adding 1 plus 2. That means you're adding those two terms, you're adding those two terms, you're adding those two terms, and you're adding those two terms. Work left to right. What is 2x plus 4x?
2x plus 4x is 6x.
What is 3y plus 1y?
4y.
And what is 2 plus 3?
2 plus 3 is 5.
Okay. Now notice what we have. We've taken our very complicated 3 by 3 and we've narrowed it down to a 2 by 2. Not only do we have a 2 by 2, but we have an easy 2 by 2. Solve that.
We would have to do elimination.
Okay.
The first one, and we would subtract them.
Oh, we're not going to subtract. We can eliminate y by adding.
Oh, yeah.
Remember that if you have a negative and a positive, when you add those two together, you get 0.
I kind of keep forgetting that the signs,
that's why
the signs equal.
10 minutes on that page every night. I'm telling you, you spend 10 minutes on that page every night, you will no longer have that problem.
It would be, so they would cancel out, so it would be 3x
Not
equals
3x, we're adding.
Oh, it would be 9 and then 1.
No.
It would be 15.
Okay. Yeah, you cannot use the rule of nines on adding. It's only for multiplying.
I know. I was saying it's 9, but then I was looking at it as the 6 take 1 from 6 and give it to 9, and then 9 will
No
equal
problem
10.
with you doing it that way. As long as you don't do it 9, 10, 11, 12, 13, 14, 15. That's
Okay.
what I don't ever want to see you doing.
All right. So
Prefer is that you actually memorize that 9 plus 6 equals 15. Eventually you will memorize that. It'll sink in. If you practice those things enough, you can't help but memorize it. You just will. Okay? So, x is equal to 18 divided by 15. Now, once you've solved for one variable, now you work your way backwards through the problem. Because I've solved for x, I can go into either that equation or this equation and substitute x and solve for y. Well, that looks like a little simpler equation. Let's do that. It's going to be 6 times 18 over 15. That's what x is. Plus 4y equals 5. Now, I only wrote it over here just because I needed space for writing. Okay? The fact is that now you can see that you have one equation and one unknown. And since I made this up off the top of my head, we've got complicated fractions. I didn't really want that. It's not useful. It's not helpful. What's important to realize is that can you solve that for y? If I said your life depended on it and you had an hour, could you solve that for y?
no.
Yes. You have one equation and one unknown. You can always solve for it, as long as you have the same number of equations as you have unknowns.
I'm just confused how to solve that with the fraction.
Okay, let's do it. We got 108 fifteenths plus 4y equals 5. You with me so far?
I'm confused how we got 100 in 8.
6 times 18 is 108.
Oh, okay.
Okay? Now, I'm trying to get y equals something, so I got to get rid of this. So I'm going to subtract that from the other side. So now I got 4y equals, well, 5 is 75 fifteenths minus 108 fifteenths. That is minus 33 fifteenths. And now I got to divide all that's 4y. So I got to divide that by 4. That gives me minus 33 sixtieths. Now,
That is so confusing.
well, it's confusing because they're fractions. If I was looking at a book and I gave you a problem that had all whole numbers, it wouldn't be confusing. One reason it's confusing is because I made this problem up in my head. And I don't know how to make a problem up in my head that has 3 perfect integer answers. Nonetheless, you should not have any problem solving that. That's just fractions.
Got it.
Okay? Let me just finish this and then we'll go back to how we solve that. I have now solved for x and I've solved for y. Well, this equation only started with 3 variables. So if I go up to any of the first 3 equations, substitute my answer for x, substitute my answer for y, now I'm going to have one equation and z is only going to be the only variable. I'm going to be able to solve for z easily. Just arithmetic. So I've solved for all 3 variables. But you have to do it in a very, very methodical way. You have to create these 2 equations, 4 and 5, both missing the same variable. In other words, I can't eliminate z to get equation 4 and then eliminate y to get equation 5. If I eliminate z in the first to get equation 4, I got to make sure I eliminate z to get equation 5. In other words, when I get to my equation 4 and 5, I need 2 equations and only 2 variables. And we're going to assume that once you get to 2 equations and 2 variables, you can always solve it. You should be able to if you can't by now. And so once I narrow it down to this 2 equations, 4 and 5, I know I can solve for x and y. Once I solve for x and y, I can go back up to one of my 3 original equations and solve for z. Now, let's go down and talk about how I solve this simple equation.
But would z equal 0?
No,
Though?
I don't know what z is because I ended up with such ridiculous fractions. I don't want to spend the last 10 minutes of our time doing fractions.
Sorry.
That's okay. We're going to do some fractions anyway, whether we like it or not. It's just that you should be beyond this point. You shouldn't need work with fractions. You are way beyond that when you're talking about 3 equations and 3 unknowns. You got no hope of doing 3 equations and 3 unknowns until you can master that page of arithmetic. And I'm serious. You can't go beyond math without doing that. You got to master that. So your very, 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 very first step should be to spend some time on that web page. Get so you are perfect. Okay?
Okay.
All right, let's talk about solving this problem here. I'm multiplying a whole number by a fraction. I'm multiplying numerators. That's 108. Put a 1 under that if you want. 1 times 15 is 15. So 6 times 18/15 is 108 over 15. Plus 4y equals 5. Now, my y is on the left side. It's already got a positive coefficient. I'm going to leave it there. So I'm going to move my 108 over 15 to the other side. So now I got this. Now, you got to be able to know how to do that. How do I do that process?
I don't know.
How do you add or subtract fractions?
You have to, like, to add them, you have to times the fractions where they can, where the...
You have to find a least common denominator. That's the only answer to that question. How do I add or subtract fractions? You find a least common denominator. What is the least common denominator in those 2 numbers?
I want to say 3, but it's not.
Not 3, it's 15. 5 is 5 over 1. Okay? So I'm looking to put everything in 15ths. Well, if I'm going to have a least common denominator of 15, well, I already know that's 108. What's this numerator got to be? Remember, this number has to be 5. So what does that numerator have to be? This is why multiplication and division is so important. Calculators aren't going to help you here. You've just got to know that 5 times 15 is 75. So 75 divided by 15 is the same as the number 5.
Okay.
The advantage of it is that now I have the same denominators and I can operate on the numerators. Well, 75 minus 108 is a negative 33. Common denominator stays the same. That's all equal to 4y. Okay? Now, I'm trying to solve for y, so I got to get rid of that 4. How do I get rid of that 4?
By dividing.
Okay? I'm going to divide that side by 4. I'm going to divide that side by 4. Well, now I get y equals negative 33 divided by 60. Now, that does simplify. We probably ought to do it just because you should not, in general, ever leave an answer unsimplified. The reason I know that simplifies is because I can divide top and bottom by a number. I can divide the top by 3, which gives me minus 11. And I can divide the bottom by 3, which gives me 20. So minus 33 over 60 is the same as minus 11 over 20, and that's what y is equal to. So that was at most complicated arithmetic.
I somewhat understand it. It's like just...
Go back to the beginning. Add these two fractions.
Oh.
See, multiplying and dividing fractions is a piece of cake. It's adding or subtracting them that's hard. And that's true whether you're talking about numbers or variables. Adding and subtracting is far harder than multiplying and dividing. So my first step, I do not have the same common denominator. I got to come up with a least common denominator. What is it?
It is 12 on both sides.
Okay. Now I got to figure out what numerator has to go there such that this thing equals 1/3.
4 goes on the left and 5 goes on the right.
Not 5. Divide 4 into 12.
Oh, divide 4 into 12?
Uh-huh.
I thought we had to...
3 12
okay.
is the same as 1.
Oh.
So now add those two numbers, now that you've got a common denominator.
7 over 12.
You got it. Now, piece of cake. I'm just going to make it slightly harder. What's the common denominator?
The common denominator is 12 again.
What goes here?
What goes there is 8.
Right. And the way you got that was you divided 3 into 12 to get 4, and you multiplied 4 times 2 to get 8. And then you saw that 8/12 is the same as 2/3. So that's really what you're doing every time, is you're dividing that into your common denominator and multiplying it by the numerator. And again, over here you have 3. So what's that answer?
That answer is 11.
11/12.
11/12. I'm sorry.
All right, now I'm going to show you how easy dividing fractions is. Looks like a hard problem, right?
Kinda. I think
How do you divide fractions? What's the rule?
you have to divide
Flip.
bottom.
Flip the bottom and multiply.
What do you mean by flip the bottom?
Here's the bottom is 5/8. I'm going to flip it. I'm going to reciprocate it.
Oh, okay.
Okay? So the problem is now not a division problem anymore. It's a multiplication problem. Piece of cake. What's the numerator?
The numerator would be 15?
2 times 8. What's the denominator?
15, I think.
There's your answer.
Yeah.
In other words, that was an easy problem. Because all you got to know is that when you're dividing by a fraction, you have to flip the bottom and multiply. And I could have written it like this. Same problem, exactly. I'm still dividing a fraction by a fraction. but I'm going to turn it into a multiplication problem. I'm going to make it 2/3 times 8/5. So all you have to remember, it's kind of like changing subtraction to addition. You change the sign, and then you change the sign of the whatever was being subtracted. Well, when you divide by a fraction, you first of all flip the bottom fraction and multiply. That's it. Far, far easier to multiply and divide than it is to add or subtract. If I said add those two fractions, that's a hard problem. What's the common denominator?
I don't know.
24. You can always multiply those two numbers to get a common denominator. It won't necessarily be the least one, but you don't really need it to be the least one. You just need a common denominator.
So you're saying we like times the denominators to get the...
Always.
Okay.
Always.
I thought we had to like do it.
Let's do
Okay.
2/3 plus 5/8. And I always want you to do it this way. And by this way, I mean draw your two fractions down there, find your common denominator first, and now go from there. Now, what's that?
That is...
Remember, you divide 3 into 24, take your answer, multiply it by 2.
Multiply it by 2? What?
3 goes into 24 8 times.
Oh, so 8 times 2 is 16.
So 16/24 is the same fraction as 2/3. That's what we're trying to do, is come up with exactly the same fraction, only with a denominator of 24. Now,
so we're taking a simplified fraction and putting it back into its like complicated state in a way?
Because we want a denominator of 24 on both. We can't add these things as long as they have different denominators. So we gotta come up with a denominator that's the same for both. Now, what goes in this numerator on the right? Do the same process. Divide 8 into 24, take your answer, multiply it by 5.
So 15.
Now just operate on the numerator. There's your answer. Notice how much harder it was to add than it is to multiply or divide. Adding and subtracting is by far the more difficult process.
All right.
All right, Josh, I'm going to let you go. Please spend some time on that page. And I promise you, you will not regret it. You will love your newfound math skills. As long as you have confidence in your arithmetic ability. You've never had confidence in your arithmetic ability, and you can't really get by that. If you don't have confidence in your arithmetic ability, you're just stuck there. It's like you're trying to build a house on mud. You're never going to get it done. You got to have a concrete foundation.
Got it.
All right. I will talk to you next time, which I believe is tomorrow at 4.
Okay.
All right?
Yep.
All right. Have a good night. Talk to you then. Bye-bye.
You too. Bye.